Yeah, next to concept of interval, second one. Before that, first of all, I want to explain what is meant by real number line. A directed line containing real numbers. This is a straight line containing real numbers. Okay, all real numbers are there on this line. For example, we want to identify where is 2 here. We want to identify where is 1 by 2, somewhere in between 0 and 1. We want exact location of 1 by 2. We need to draw the perpendicular bisector of this line segment. So this is the exact location of 1 by 2 on the number line. Okay. For example, you want root 2 on the number line, root 2. Root 2 also real number only. So do one thing. This is number line. Here 0, here 1, here 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we want to find the root 2 on the number line. Take number line and at 0 draw a line perpendicular to given number line. With the help of a compass, identify point here, say A, so that OA equal to 1. So this is say B. OB is 1 unit, OA also 1 unit. Join AB. So this is 1 unit, this is 1 unit, is right angle triangle. So hypotenuse square equal sum of squares of other two sides. So this is x square equal 1 square plus 1 square, x square equal 1 square plus 1 square. So x square equal to 2, x equal to root 2. So this is the length root 2. Now take compass, take AB as radius, O as center, draw an arc on number line. Okay. With the help of compass, take AB as radius, O as center, draw an arc on the number line. That arc intersect the number line at somewhere point C. So automatically OC nothing but root 2 now. OC nothing but AB only, no? AB and OC both are same. OC nothing but root 2. So C is the location of OC means root 2. So this is the location of root 2 on the number line. So what happened on here? 1 after 1, 2, 3, 4th. So I can say that the value of root 2 is 1.4. We want the value of root 2 more, some more decimal points. We need to zoom this area. So after zooming that, we will get 1.41, 1.414, like that. We can identify root 2 on the number line. First of all, I identified 2 on the number line. Next, I identified half on the number line. Next, I identified root 2 on the number line. Similarly, every real number you can identify on the real number line. That's why this line is called real number line. Now, A is a set of elements x such that x is a real between 2 and 5. X is a real number between 2 and 5. Means the x is a real number lies between 2 and 5. Not equal to 2, not equal to 5. Between 2 and 5. Means that may be 2.00001. It may be 2.00007 to up to 4.99999. But how to write it symbolically? Okay. So x is greater than 2. X is less than 5. So we can write x is greater than 2 and less than 5. We can read it as 2 less than x less than 5. Means x is a real number lies between 2 to 5. Or another way also we can write it. So symbolically this can be written as x belongs to ordered pair 2, 5. Or actually you need to read as x belongs to open interval 2, 5. Open interval 2, 5. The meaning of this notation, x belongs to open interval 2 comma 5 means x is a real number that lies between 2 to 5, not equal to 5, lies between 2 to 5. Okay. For example, another set B is given as x such that x is a real between 2 and 5 also equal to 2 and 5. So next one, x is a real number between 2 to 5 and also 2 and 5. It may be equal to 2, it may be equal to 5 and lies between 2 and 5. So x is such a real number that is greater than 2 and may be equal to 2 and less than 5 and may be equal to 5. So we can read it as 2 lesser than or equal to x lesser than or equal to 5 means x is a real number lies between 2 to 5 and including 2 and including 5. So another way you can write it as x belongs to box 2 comma 5. Box 2 comma 5. How to read it, that is important. We can read as x belongs to closed interval 2 to 5. Closed interval 2 to 5 means if x belongs to closed interval 2 to 5 means x is a real number lies between 2 to 5 including 2 including 5. Here what happened? X belongs 2 to 5 only. X is not including 2 and not including 5. Lies between 2 to 5. So here x may be 2, x may be 5 and between 2 to 5. Okay. So this is the concept of open interval. This is the concept of closed interval. Okay. Types of intervals. Open interval. Closed interval. Third one, semi-open or semi-closed or semi-open, closed. There are three types: open interval, closed interval, semi-open or semi-closed. This is open interval. This is example of open interval. This is closed interval. Okay. For example, x is greater than or equal to 2. X value is 2 or more than 2 and less than 5. So you can read as 2 lesser than or equal to x less than 5 means x is a real number lies between 2 to 5 and equal to 2. So you can write this one as x belongs to closed to open 5. Closed to open 5. This belongs to semi-closed concept or semi-opened. Okay, x belongs to closed to 5 means x is a real number lies between 2 to 5 including 2 and but not include 5, excluding 5. Okay, so similarly, so 2 lesser than, x lesser than 5 means x is a real number lies between 2 to 5, so including 5 but not include 2. This can be written as x belongs to open to closed 5. Open bracket to closed bracket 5. We can read it as x belongs to open interval to closed interval 5. So there are three types of intervals now: open interval, closed interval, semi-open. Okay, open interval in some books they will write like this: open 2 to 5, open 2 to 5. Same meaning. Same meaning. X is a real number lies between 2 to 5, not equal to 2, not equal to 5. Okay, open interval, closed interval, box, closed interval. Next, semi-open, semi-close. This is the concept of intervals. Open interval. Second, closed interval. Third one, semi-open or semi-close. Okay, open interval. A less than x less than b, or you can write x belongs to open interval a comma b. Both are same. Means x is a real number lies between a to b, not equal to a, not equal to b. Closed interval. A lesser than or equal to x lesser than or equal to b. Means x is a real number lies between a to b and including a and including b. This can be written as x belongs to closed a to b. A lesser than or equal to x less than b. X is a real number lies between A to B, equal to A but not equal to B. This can be symbolically written as X belongs to closed A to open B. Or A less than X lesser than or equal to B can be written as X belongs to open A to closed B. This is important concept. Interval concept is important. Okay. So set A is given as 1, 2, 3, 4. Set B is given as 2, 3, 7, 9. Okay. We want to find A union B. Sometimes we want to find A intersection B. Sometimes we want to find A minus B. How to find union of two sets? How to find intersection of two sets? How to find the difference of two sets? Union. U stand for addition, just like add. Means all elements should write. Add means all elements. Don't add the elements. You need to write all the elements which are in both A and B. So here A union B means 1, 2, 3, 4, 7, 9. Don't write 2, 3, 2 times there. No. 1, 2, 3, 4, 7, 9. All the elements which are A and B should write. That is nothing but A union B. Intersection means common elements. Common. A intersect common. See, 1 no common. 2 is common for both. 2. 3 is common for both. Only 2, 3. A intersection B means 2, 3. A intersection means the common elements which are in A and B. Okay. A minus B means from A you want to remove the elements which are in B. From A we want to remove the elements which are in B. 2 is there, should remove. 3 is there, should remove. Remaining elements in A is called A minus B. Only remaining elements in A. Don't bother about elements in B. In B, 7 and 9 is there. Don't bother about B. So A minus B means set of elements which are in A but not in B. That is the definition. Okay, students. Important notation. X belongs to closed 2 to open 3 or open 5. X belongs to closed 2 to open 5 means X is a real number lies between 2 to 5 including 2 but not equal to 5. How to represent this on number line? Important. Draw number line. 0, here 1, here 2, here 3, here 4, here 5, here 6. So what this says? Any real number between 2 to 5. 2 is included now. You need to write a thick circle at 2. 5 not included, open circle. So we need to shade it. So in this way you can represent these real values of X on the number line. Okay, one more example. X belongs to open 2 to open 6 given. Represent these real numbers on the number line. So first of all take number line. Here 0, here 1, 2, 3, 4, 5, 6, 7 like that. Open 2 to 6 means in X is a real number between 2 to 6 not equal to 2, not equal to 6. At 2 you need to write open circle. At 6 also you need to write open circle and we need to shade between those area between those two open circles. So the shaded region is represented by this set X belongs to 2 to 6. This is also one of the set representation only. This infinite set. For example, A is given as 1, 2 means this finite set, only 2 elements. A is equal open bracket 1, 2 means it is not a finite set, it is infinite set. Infinitely real numbers are there between 1 to 2. Okay, infinite set. So this is the representation of infinite set. This is representation of infinite set. This is representation of infinite set. This is representation of infinite set. So open intervals also another form of a set. Okay, students, one example problem. A is a set of elements X such that X belongs to closed open interval -3 to open 2. X is a real number. So set B is given as X such that X belongs to closed -4 to closed 5. X belongs to R. First one, find A union B. Second one, find A intersection B. Third one, find A minus B. These three should find now. Okay. So listen all of you. By using number line only you can find the value of A union B, A intersection B, A minus B. That only the easiest way. First of all, draw number line. Okay. Minus 4, okay. Minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. Okay. What is says A? A is closed minus 3, closed minus 3, closed minus 3 to open 2, to open 2. I will write like this. My yellow, my pink one is set of elements, closed minus 3 to open 2. That is represented by set A. Next, set B, closed minus 4 to closed 5. Closed minus 4. I want to use another color. Closed minus 4. Closed means thick circle at here. To closed 5. So these values. All. Okay. Now what do you want? These values in the set A. These values are in the set B. First of all, A union B you want. A union B. X such that. So A union B means all elements. Union means you need to combine all the elements. Minus 4 to 5. Minus 4 to 5. Okay. So what happened, Anna? X belongs to minus 4 closed to closed to 5. This is A union B. Next, A intersection by I want. Intersection means what? Common elements. Common elements. See, this area is common. This area is common for both. This area is common. That's why I can say that X belongs to closed minus 3 to open 2. This is the A intersection B. A minus B. Interesting one. A minus B. Definition saying that from the set A, we want to remove the elements which are in B. A set. Where is set A? Pink one. From this set, we want to remove the elements which are in B. So here B only bigger set means you need to remove all elements. So what happened, Anna? Empty set will get. So in this situation, in this example, so clearly, so A is a subset of B. A is a subset of B here. A is a proper subset of B. That's every element of A is in B. That's why A minus B is empty. So I will use another example. A equal to X such that X belongs to closed minus 3 to open 6. And B is equal to X such that X belongs to open minus 1 to closed 7, for example. Now we want to find again A union B, A intersection B, A minus B. First of all, draw number line. Okay. So here minus 3, here minus 1, here 6, here 7. So what says X? Minus 3 to 6. Minus 3, closed to open 6. So these values, this box means all these values from minus 3 to 6 belongs to set A. Now set B, that is closed minus 1, closed, open circle, closed circle to closed 7. This. Now we want to find A union B, A intersection B and everything. So I will write, observe here. A union B I want. Union means all elements. All elements from this is set B, this is set A. All means minus 3 to 7. Minus 3 to 7. X such that X belongs to closed minus 3 to closed 7. This is the A union B set. Okay. Next interesting thing is A intersection by I want. A intersection means common element. This area is common for both. See, observe. This area is common for both. This area is common. What is that, Nana? X such that minus 1 is there but 6 is not there. So X belongs to closed minus 1 to open 6. Close it. So this is A intersection B. Next what I want? A minus B I want. A minus B. X such that A minus means A from A. A means this set. From A I want to remove the elements which are in B. Means all these elements should I remove. All these elements should I remove. So minus 3 to minus 1 left. So minus 3 closed. Actually minus 1 is there in the set of A. So that minus 1 also there in the set of B, that should be removed. That's why this minus 1 should be removed. That's why open minus 1. So we can remove minus 1, but you can't remove the element which is left side of minus 1. That's why closed minus 1 to open minus, closed minus 3 to open minus 1 is the solution. This is for A minus B.